Okay, so to begin the second half of our presentations, the speaker I'm about to introduce is one of our BA physics students, and this is going to be an example of an educational capstone, so an instructional design project, a project based around teaching. And when I first spoke with Cody, I was thinking to myself, what is it that I think is one of the hardest parts about being a teacher? And one of the hardest parts, in my opinion, about being an educator is trying to remember what it was like not to know the thing that you're teaching. The longer you teach it, I'm pretty sure I taught you this 3 years ago. You should know by now what it's going to be, but you have to keep that in mind. What was it like to go on this journey? And so when I was going to work on Physics 114, I was exceptionally grateful to have a student who'd been integrated into that course for many, many semesters previously. So I was more than happy to exploit his wisdom and knowledge on a subject to make myself look good. So, with that said, let's give a warm welcome to our speaker, Cody Kojima.
Thank you for that introduction, Dr. Target. But so this is a good detour because we've been to like nanowires and galaxies and the sun and all that. But now we'll take it back to the classroom where it all began. So my capstone project is creating better worksheets for Physics 114, Introduction to Physics 1. So to start off, what is Physics 114? The course title is Introduction to Physics 1, and it is the first of 3 sequential physics courses that are calculus-based taught here at Sonoma State. Some topics that are taught are classical mechanics, which involve the study of motion, kinematics, dynamics, so Newton's laws, energy conservation, and rotational motion. And as far for the students that do have to take it, the majors are BS in math, BS in chem, so Tanner actually knows about this course, biochem, electrical engineering, computer science, and all physics majors. And the reason why this course is so important is because it is the foundation upon which all these other crazy concepts that are taught later on in all of these majors, like Tanner said actually in chemistry, it'll come back and it's all related. So it's important to have a strong foundation to build up upon. So my past experience with Physics 114 is I've been the supplemental instruction or the SI leader for 2.5 years, which is basically equivalent to a TA. I make my own office hours, and along with sitting in the class, students come during those office hours, and I help them with homework problems, any questions, or previous exams. And one of the main concerns that came up over the past 2 years is that the homework the students felt was inadequate. So my idea for the project is that if I can create better homework, that means the students will have a better understanding, and hopefully that'll reflect in exam grades or final grades. So that's what the project was. So to start off, it's a good idea to show you what the old worksheets look like. There's nothing wrong with them, just trying to improve on them. But it's 5 to 10 medium to difficult problems with the answers given like so. And this is a zoom up on one of the problems. Great test problem, multiple steps. Centripetal forces involved, centripetal acceleration, and tension. But just the problem with this was students were not understanding how to integrate all 3 of these concepts and see how they're related, and then to be able to solve a complex problem like this. So the idea I did with Dr. Target was we would create a new homework with a strong foundation or a strong core to teach those individual concepts to build up to a more standard or test problem, an example of a test problem, or like the old worksheets. And then we decided to put one advance or one problem to evoke some sort of critical thinking, as that's a very important skill to have in physics and any STEM major. So this is the new idea behind the new worksheets. And this is what they turned out to look. And this was what my project was. For every different section for exams, I would make a new worksheet and have Dr. Target look over it, evaluate it, and just coming up with new drafts until we finalize that new homework. So all the new homeworks were comprised of 10 core problems. In this case, there's 3 here, but 10 core problems to really let them practice those individualized concepts in order for them to build up to 3 standard problems, which are similar to what they would see on exams, not exactly, but similar. And these standard problems, this is one standard problem right here. It's multi-part, and they would be able to take these core concepts and be able to integrate it into how they all connect and be able to solve a standard problem like so. And then lastly, we had one advanced problem for the critical thinking, just to make them think outside the box. So this is just an in-depth look at what the new homework standard question. So these would be examples of the concepts covered in the core part of the new worksheets. So how rotational velocity relates to linear velocity, how rotational kinetic energy is, or a rotational kinetic energy problem and a rotational kinematics problem. And then with these core questions, so this would be like a 1, 2, 3, they would be able to understand how they all come together to fit into one problem. In this case, this is a rotational energy problem. So in terms of analysis, the idea was I was going to take last semester's grades, and because last semester is when they use the old homeworks, and do an analysis with the new or the current semester grades, which is they would be doing the new homework. And I came up with several problems. One being that at the time of the research, I do not have the final grades for this class specifically. So that's already one. It's already not even analyzing the same exact things, as there's more that goes into a final grade than just the exam scores. There's participation, attendance, and the homework scores along with those exam scores. But not to worry, that I know does not look promising this semester. But once we do calculate all the participation, attendance, and homework, we expect to see more of a shift towards that way when the final grades do come in. But for the sake of my project, this was a really big problem. So yeah, once again, the problems with this analysis is that the population size this semester is only 39 students, which isn't a large population, and it'll make it very difficult to do a one-to-one comparison between my worksheets and the old worksheets. Along with the variations within each class. This semester, there's not as much physics students as last semester. Along with the final grades versus exam grades, it wasn't even testing the same thing. So I really had to come up with something new for this project. So some adjustments I made was that I would not be analyzing the old homeworks. I would need a much larger sample for that. But instead, I will be analyzing my homeworks that I made and seeing if whether students completing them or not completing them had any effect on their average exam scores. And this study was conducted with 4 exams and 4 of my new homework. So once again, I'll show you this horrendous distribution of average exam scores for this semester. And when you split those into 2 groups, for students who completed 2 or less of the homework, these are their distribution of average exam scores versus students that completed majority of the homework. So we can already see a pretty big difference. There's a bimodal action going there on the students who completed majority of the homework. So interesting points to note. For students that didn't complete majority of the homework, their average exam scores, there were no A's versus the 5 A's and 2 A minuses that students who completed majority of the homework. So that's a pretty good indication that doing the homework lets people do better on the exams. Another key observation is that students on average who did complete the homework always did better than students who did not complete the homework on all 4 exams. So once again, that's a pretty strong indication that students should be doing the homework. But to really get some sort of statistical analysis and to see if there's any statistical difference between completing the homework and not completing the homework, I decided to run the Mann-Whitney U test, which is a non-parametric statistical test that is based on ranks. So we separated the 2 groups, group 1 and group 2 respectively, and took those scores and gave them a rank, with 1 being the lowest rank and 39 being the highest average score or highest rank. And what this test does is basically it takes the two groups, group 1 and group 2, it sums up those ranks, and we calculate a U statistic, which is basically the overlap between the two groups. So if this U statistic is small enough, meaning the overlap is small, we can say that there is a difference between, in average exam scores for students that completed it versus students that didn't complete it. So that's what we're looking for, is a small U statistic. And so I'm a physics major. I was forced to do some math in my project. But yeah, basically keep this picture in mind. I calculated a U statistic of 95.5. That's the overlap between the two groups. And using the Mann-Whitney U table, a critical value of 99 given the two different populations, group 1 being 19, group 2 being 20, we get 99 as the critical value. Because our U statistic is less than the critical value, we can reject this null hypothesis, which basically says there is no difference between completing and not completing homework. We reject that, and we can accept that there is a pretty strong correlation in better average exam scores with students that complete the homework, which is a good sign. Because if it were the opposite of this, I would have failed massively. But, so in conclusion, we were able to prove that students who do majority of the new homework I created tended to get better average exam scores, which is good. But this would be better designed to be more of a longitudinal study, being that the original goal was to see if these homeworks were better than the old ones, but given the population, the group sizes I have, and the time I only had this semester to conduct this research, it's hard to get that exact if the old homeworks are better than the new homeworks. But yeah, hopefully Dr. Target will continue to use these new homeworks and see if there is actually a difference as the population size grow longer. But this is a good stepping stone for future study. And I would just like to thank Dr. Target for letting me do this project with him and allowing me to be his SI leader again. But that's it. Thank you.
Questions for Cody?
Questions?
Well, I'll ask one.
Yes.
One of the tests looked very strikingly different. I don't know, was the topic matter something there that you thought was important? Would you say that, yeah, one forward? Yeah, that one, the upper right one, right? Where the scores seem to be so dramatically different. Mm-hmm. Do you remember which topic that was? And I
believe with this, the topic was dynamics, so forces, Newton's laws. I think students just really underestimate how complex it can be, and they start off not doing the homework and being able to get away with it, but they'll soon see, like, if you don't study and don't give in that time, there's a big difference in grades. So then they usually kick it up a notch, though, by the end, once you do see that F.
That's where they're learning.
Yeah.
That's where they're learning it.
Once you see this, yeah, it's really easy to step it up a notch. But
Other questions for Cody? Well, let's thank him again.
All right,